This is Honors Geometry, area of circles and sectors. So first of all, what is a sector? A sector is a region bound by two radii of a circle and their intercepted arc. So in other words, it's a slice of a circle. It's like a slice of pizza. And then just as a review, remember the area of a circle is pi r squared. So we do have to have the radius. When we were doing the circumference, we could use the diameter, and if they didn't give us the diameter, we would multiply the radius by 2. Now we have to have the radius. So if they give us the diameter, we're going to divide it by 2. All right, so we're going to set up a proportion just like we did for arc length. So our question is, what fraction of the whole area of the circle is our sector? So as we did before, so say you have a circle and say that the area was 12 pi units squared. And if we took half of that circle, we would know that the area of this sector is 6 pi. If we took a quarter of it, we would take 1/4 of the 12 pi, and we would see this is 3 pi. So again, what happens if it's not a nice even number like a half or a quarter? We're going to say what fraction of the whole circle is that sector. So we want to know out of 360 degrees, what portion do we have? So we're going to set up a proportion again using two ratios. So the ratio of the area of the sector, our slice of pizza, is to the area of the whole circle. So we're saying what fraction of the whole circle is that, as the measure of the arc is to 360. So let's go ahead and practice that. So for this one, our formula again is, I'm just going to call it S for sector, is to A for area of the whole circle. What fraction of the whole circle is this? As the measure is to 360. Okay. So again, this section we're looking for sectors. So I'm just going to leave that as my unknown. Area, remember, of circle is pi r squared. Have to have the radius. So I'm just going to call that 100 pi, 10 squared times pi. They're telling us the measure of this, remember, is the same as the central angle, so it's 60 degrees. So it's 60 out of 360. If you want to make your math a little bit easier, you can simplify that. 6 goes into 6 once, 6 goes into 36 6 times, so we can change that 60 over 360 to 1 over 6. And then we're going to cross multiply. 1 times 100 pi gives us 100 pi. And S times 6 gives us 6S. S is the area of our sector. Divide each side by 6. Oops, I'm calling it S equals. So I'm going to take 100 pi and divide that by 6. And I get about 52.35. Does it tell us how to round? No. So we're just going to say 52.4, we'll call it. And that would be square inches. Let's try another one. So our proportion again is, let's try a different color here. The area of the sector is to the area of the whole circle, as the measure of the arc is to the whole circle, which is 360. Our sector is our unknown, so I'm going to leave that as S. The area of the circle is pi r squared, or 14 squared pi. 14 squared is 196. So just to make things easy, I'm just going to leave pi as pi for now. The measure they're telling us is 256 degrees. 256 out of 360. Let me go ahead and simplify that to make our math a little bit easier. So 256 over 360 looks like it simplifies to 32 over 45. That's a little bit better, not a lot. All right, here we go again. It's time to cross multiply. So I'm going to take 32 times 196 pi. And that gives me 6,272 pi. I'm just going to leave the pi there for now. And that equals 45 times s. Cross multiplying the other way. So now I'm going to divide each side by 45. So I'm going to punch in my calculator, 6,272 pi divided by 45 and see what we get. 6,272 pi divided by 45. The longer I can leave pi in my calculator, the closer to the actual number I'm going to get. And that's telling me the area of this is about 437.9 square centimeters. All right, let's talk about other shaded areas in a circle. This one's called an annulus. It looks like a donut. It's a hole cut out of a circle. So we're just going to take the area of the whole circle and then we're going to subtract the area of the hole missing. So the official formula is pi capital R squared minus pi small r squared. So in other words, the area of the whole circle minus the area of the missing piece. So I'm given that the radius of the whole circle is 4. So I'm going to say 4 squared. Minus the area of the whole, which would be 2 squared pi. And so I get 16 pi minus 4 pi. That's going to give us 12 pi. And you can leave it as 12 pi square inches if you want. Or we can punch that in our calculator. 12 pi is about 37.7. So the area of the shaded region is about 37.7 square inches. The next one, it looks like we have a triangle, a right triangle, sitting on top of a semicircle. So we're just going to add that together. So the area of a triangle is 1/2 base times height. And then the area of a circle is pi r squared. But remember, we only have half of a circle, so we're going to divide that by 2. So the base of our triangle is 7. The height of our triangle is 4. Our radius, you can see, is half of this 7, or about 3.5. And then again, let's not forget to cut that circle in half because we only have half of that circle. So I'm going to punch that all in my calculator. And I'm getting about 33.2 square feet. Let's look at a couple more classic questions. This is a great test question. You have a square with a side length of 32, and there's holes cut out of it from touching from side to side. What's the area of the shaded region? So the first thing I would do is I would take 32 and divide it by 4, because we know we get 4 circles across. So 32 divided by 4 tells us each of these are 8. So if each circle has a diameter of 8, that means it has a circle, it has a radius of 4. And it's the same here. So I'm going to find the area of the square, which is 32 times 32. And then from that, I'm going to subtract. It looks like we have 16 identical circles with the radius of 4. So I'm going to subtract 16 times 4 squared pi, and that should give us our shaded region. So 32 times 32 is 1,024. And then 16 times 4 squared pi is about 804.25. And now I'm going to punch that all in my calculator. that's about 219.75. So if this was metal and you were cutting circles out, that's how much wasted material you would have, square centimeters. Last one, it's a square inside of a circle, and you can see that the diameter of the circle is 16, which means our radius is going to be 8. But it's also the diagonal of this right triangle. And you can think back to your 45, 45, 90 triangle. You can say that's x root 2. You can set x root 2 equal to 16. Or you know that the sides of a square are the same. We could use good old Pythagorean theorem. We could say that x squared plus x squared equals 16 squared. 1x squared plus 1x squared gives us 2x squared. 16 squared gives us 256. We can divide each side by 2 to get rid of that. Gives us 128. Square root of 128 gives us about 11.3. So we know the side lengths are about 11.3. Okay. And again, you could have used your 45, 45, 90 triangle for that. All right, now let's get to work here. So we're going to find the area of the circle. We know the diameter is 16, which means the radius is 8. So we have 8 squared pi. That's our circle. And we're going to subtract out this square, which is 11.3 times 11.3, or 11.3 squared. All right, here we go. 64 pi minus 11.3 squared gives us about 73.37. We'll call it 73.4 square feet. Please try the practice problems. Let me know if you have any questions. Thank you.